A hotel finds that on average it can rent 90 rooms when it's priced at $60 per room and 75 rooms when priced at $70 per room. So, assuming the number of rooms rented is linearly related to the price, what price will maximize revenue for the hotel? So, we have two steps that we want to think about here. The first step is setting up an equation that shows the linear relationship between price and number of rooms. And then once we have that relationship, then looking at the revenue function and how we can maximize that. So if we think about our input being the price, we'll call that P, and our output being the number of rooms, we'll call that N. So we're told that this is a linear relationship between number of rooms and the price. So we could think of it in that y equals mx plus b format, or in this case, n, the number of rooms, is equal to the slope times the price plus some initial value, b. So we can take the two situations that we're told about and think of those as ordered pairs, the input being the price and the output being the number of rooms. So we could have one ordered pair, $60 as our price, gives us an output of 90 rooms. $70 as our price gives us 75 as our number of rooms. So let's find our slope. So 75 minus 90, our outputs in the numerator, all over 70 minus 60, we end up with negative 15 over 10, or negative 1.5. So this is telling us, since it's a negative slope, for each dollar they raise the price, they fill 1.5 less rooms at this particular hotel. So taking that value and one of our points, we can find the b, our initial value for our linear relationship. So we've got that n is equal to negative 1.5 times p plus b. So pick one of our points. I'm going to use the first one. So 90 equals negative 1.5 times 60 plus our b. So I have 90 equals negative 1.5 times 60 is negative 90 plus b. And adding 90, we have 180 is equal to b. So this is telling us that n, the number of rooms, is equal to negative 1.5 times the price plus 180. So think about what this is telling you. If P were equal to 0, price was 0, the number of rooms filled would be 180. So we could assume there's 180 rooms at this hotel. If they're giving them away for free, they could fill all of them. That would be all 180 rooms. So now kind of save that thought. Now let's come and think about revenue. So the way that a hotel makes revenue is taking P, the price per room, times N, the number of rooms that are filled. So if you have 50 rooms and you sell them each at $100 a piece, this would tell us a revenue, the amount of money that is coming in. Well, we know a relationship between N and P. So what I'm going to do is I'm going to take this equation that we just wrote and I'm going to plug it in to my revenue function in place of the N. So this gives us a way to rewrite our revenue function as R is equal to P times, instead of N, I'm going to write that as negative 1.5 P plus 180. Or if we distribute, we have R is equal to negative 1.5 P squared from P times P plus 180 P. So this is now a quadratic function where A is equal to negative 1.5, B is equal to 180, C is equal to 0. So this is a quadratic that opens facing downward because our value of A is negative. And so if we want to find the maximum revenue, we can maximize our quadratic function by finding the vertex. So to find the max, we are going to find the vertex. We can use our vertex formula to do this. So the opposite of B all over 2a, so negative 180 all over 2 times negative 1.5. So we have negative 180 over negative 3 is equal to 60. So this is the input value in our revenue function. So this 60 is telling us that a price equal to $60 will maximize the revenue. Once we know this value for P, we could find several things using that. If you take that value of P and plug it back into your revenue function, it will tell you that the revenue that is made by selling rooms at $60 a piece. If you take that 60 and plug it into the linear function that we started with, it will tell us the number of rooms that corresponds to a price of $60. This happens to have been one of the values that we were given as our ordered pair, so we know that $60 corresponds to 90 rooms. If you graph about our steps, we start out with a linear relationship between N, number of rooms, and price P, and then using that relationship, we can write our revenue function as price times the number of rooms and make a substitution using our linear formula in order to write a quadratic function for our revenue. The maximum for this quadratic will occur when we find the vertex. Our vertex formula using the opposite of b over 2a can find the input value for our vertex, telling us that a price of $60 will maximize the revenue at this hotel. Function. This is what we'll see if we take a look at it in Desmos. So your revenue function we said was a quadratic function with a negative value of a. So it's a parabola that opens facing downward. You can see the vertex of our quadratic there at the point 60, 5,400. That 60 is the price, the 5,400 is the revenue that we would have if we sell rooms at $60 a piece. And then you can see some other combinations. So the point is marked there for a price of $70. We were told that they fill 75 rooms. You can see how that is a point on our parabola. However, that has a lower revenue than when we have a price of $60 per room. So thinking